So yeah, okay, good.
Yeah, and we have also the head of politician in ECA, which is responsible for management of the rest of when I was asking everyone on the first time when we were speaking today, everyone was okay, and now they're
complaining lately.
Yeah.
So when people start working together. Overdone.
No, it's okay. He was like, he was before a bit. So it's stay and but now nothing special. Yeah, that's why I was taking it there. It's hard.
When you were on the bus,
Okay. And how was the well?
Very nice, very interesting. To see that the original is amazing. Amazing.
Have you taken
No, no, sir.
very first. You're the guy from the books, the movies when they go to the class.
Yeah.
I was I don't repeat there those UK summer they have
Hey, bullet.
guys they have every specimen ever.
The National Museum of Natural History in New York is very famous and nice. And of course, it's the Peregrine Fund, the Belgium. They have this really nice library. And they have a Traité de Fontenay. And that's a French book. This size. And it's a librarian. It's on the maps. Show it to you. Because it's so, such a treasure.
Yeah, and there is some in the UK, I don't remember the name of this place, but they all specimens of almost every bird. And they also have mask, glass, everything. Extinct species. I really in the book about Cormorant. Okay. Because the guy was doing that, came there to see this spectacle Cormorant. And she goes for feeding on that. This Kamchatka eagles. Yes, eagle was feeding on spectacle Cormorant, but they were overhunted by sailors who were on this sea. But there was no food much, so they asked one Cormorant to eat like 6 people. Meat was very big, the biggest Cormorant ever.
Thank you. Yeah, it's good.
It's working.
Working and the mic goes. If not, just here.
Dobro.
Da, samo da tu stane.
Aha.
Go a bit further so I can see the screen there.
Yeah. This is the shot.
Yeah.
From this camera, so it's okay. Yes, excellent. Bolek. Budeš ti najavio, pozdravio?
Da, on sam kratko.
Ajde, pa stani si tamo pored njega, isto da te kameru lovi, da se vidi ko priča. Da, a možemo poslije predavanja? Mislim, sad treba početi.
Može bez mikrofona ili... I bolje.
I bolje s mikrofonom. S mikrofonom?
I bez mikrofona.
Ok. Dobar večer. Ja se zovem Bolek i ispred druge dio htio bi predstaviti našeg gosta. Prvo bi se zahvalio svima što ste došli u možda ne velikom, ali reprezentativnom i broju. Drago mi što ste došli, htio bih predstaviti gosta, znači o ovakvoj temi. Tema nije jako popularna, zapravo je ovo uvijek nekako negdje tu u pozadini glavnih izazova s kojim se zaštita prirode i lovstvo susreću, ali mislim da osobno je jako bitna tema i da ako imamo negdje priliku napraviti neke velike korake u zaštitu biodiversiteta, to je to od mene i Oliver, the man is yours.
Thank you very much, Molik. I don't know if I need the microphone or if you can understand me without mic. It's fine enough, but I can use it as you are. So thank you very much for the nice introduction. I'm happy and honored to give you some insight about the work we have done over the last, let's say, 20 years on this topic of lead ammunition in white-tailed seagulls in Germany. And my name is Oliver Krone, as Bolek said. I'm veterinarian in Berlin at the Leibniz Institute of Zoo and Wildlife Research. Did my PhD on parasites in birds of prey and then switched to pathology, causes of death, mortality. And because we found that lead intoxication is a severe problem in wildlife, especially in these eagles, we established the toxicology at the Department of Wildlife Diseases. So the talk is lead ammunition, a toxic enemy of life. Lead has been known for hundreds, thousands of years as heavy metal and is still used. And we are still exposed to lead. And this is what my talk is about. And we are using the white-tailed seagull as an indicator species about this problem. Here on this slide, you see 6 projectiles, rifle ammunition, half cuts. And on the left side, there are 3 bullets composing of a lead core, and on the right, these are lead-free copper or tombak-based bullets. But I will go more into detail and explain this more and more. So my talk is about lead distribution and use, who is affected, the sources of lead intoxication, the solutions to the problem, communication with the relevant stakeholders, and then the current status of the legislation within Europe. Lead, as I said, is not a real rare matter. It's mainly found as galena, as an ore, so it's in the earth crust, and it's also found as bolongerite, for example, or andesitite, and often found in combination with sulfides or in conjunction with lead in gold mining. There are several significant deposits worldwide, like in Australia, in Mexico, but also in Russia. And the global production of lead is estimated to be 10 million tons per year. And it's important to know that 50% of this 10 million tons are recycled lead, and this lead comes from batteries, mainly batteries used in cars. So lead has been used, probably it's the first metal which has been used by humankind because it's easy to work with. It has been used as opacifier and colorant for glazes and glasses. It is also been used as pigment in cosmetics, 4000 before Christ. It's a byproduct of mining, such as silver, as I said before. And cooking utensils have been made of lead, and lead piping was the mainstay of the water distribution system in the Roman Empire. And some archaeologists and scientists think that because the Romans have produced supper, which is a syrup made of sweet fruits boiled in lead vessels, they intoxicated themselves. And there are some hints on that. Some carcasses or human bodies, remains, bones have been analyzed for lead, and the Romans had much higher concentrations than their slaves, which didn't come into contact to this very sweet syrup. The characteristics of lead are that it has a very low melting point, is relatively soft, easy malleable, and has a high density in this relative inert to oxidation. These properties combined with the abundance and low costs resulted in an extensive use in constructions, plumbing, book printing, batteries, weights, solders, fusible alloys, white paints, and of course in bullets and shots. Because it's so toxic and it's known to be toxic for many, many years, it has been forbidden in electric supplies, it's forbidden to be used in paints, and it's not more allowed to be used in gasoline. But that's a more complex topic. But it's still allowed to use for ammunition. And here we have to differentiate between shotgun ammunition and rifle ammunition. And from the shotgun, hunters using shotgun shells, and this cartridge consists of many little balls, so-called pellets, lead pellets. And they can contain up to 300, 350 single pellets, depending on the size. And the rifle cartridge has just a single bullet, torpedo-shaped, and the cartridge is filled with powder, with propellant, and then this bullet is shot from the rifle. You don't need to be experts on that, but it's helpful to understand the problem on the environmental side. So this is what it looks like when you open such a cartridge from a shotgun shell. And what is the relevance? Who is affected from using these ammunition types? So it's known that diving and doubling ducks are ingesting these shotgun pellets orally because they mistake them as seeds, so they want to eat that, or they take them as grit because they need stones in their gizzard, in their very muscular gizzard, to break down fibers, plant fibers, and for that, because they don't have teeth, they need this grit in the gizzards. Here we have an X-ray picture of a whooper swan, and this contains in the gizzard, in the digestive system, 12 of these lead shot pellets. This bird died from a lead intoxication. In birds of prey, it's different. They're not taking up the single pellets directly, but they're feeding, for example, on shot or crippled prey, or just normal birds which have been shot and have survived the shot and are moving on. And then, of course, you know, these birds of prey, they might select the most weak birds first and make a catch of prey. As I said, the lead poisoning in water birds is also known for many, many years. And because of this, there was AEWA, the African Eurasian Water Bird Agreement, in which the participating countries or the signed countries agreed to mitigate all problems for migrating water birds. And that included the phase out of lead shot ammunition in wetlands for hunting water birds. Because when you hunt water bird there, you're shooting this high amount of lead shot pellets into the environment. They're sitting on the ground in shallow waters, for example, and then they're taken up by the birds. And of course, this is the lead shot pellets not only end up in water birds, depending on the small game hunting. Lead shot pellets are used for shooting pigeons, rabbits, hares, ducks, but also pheasants. And this is a cover illustration from proceedings in Oxford held in 2014. So there in the UK, pheasants are typical small game, and they are shot, and pellets are falling to the ground, ingested in this case by a whooper swan, or the common buzzard is feeding on a pheasant which has not been retrieved by the hunters. And of course, the third way is that the pheasants are ending on the table of the hunter's family, and the humans might ingest these lead pellets or fragments of the pellets together with the game meat. What is the relevance of shot in European wetlands? This is a study published by Rafael Mateo from Spain, and you see in the left upper corner the amount of shots found per square meter wetland. So this is, for example, the Ebro Delta in south of Spain, and there is very intensive water bird hunting going on, or it's forbidden to use lead shot ammunition there, but it occurred in the past. They found more than 300 little lead shot pellets in the mud in these wetlands. And depending where you look, in areas with intensive hunting, you found different amounts of these lead shot pellets in the ground. Regarding the birds, there's a prevalence of lead shot ingested, so orally taken up in the mallards, also again in the Ebro Delta, in the UK, in France, in Denmark, and in Italy, and some other countries. There are not studies from all countries, but there are enough studies to show that this is a relevant problem in Europe. And when comparing numbers from the US and Europe, here in the US more than 170,000 water birds, In Europe, more than 75,000 birds have been scanned, examined for lead shot in the gizzards, and the birds mostly affected is the pochard or the red hat, as shown here in the photo, and the northern pintail. These are the most affected birds in Europe, and when you're looking in the more endangered species, then you see there's a strong correlation between population decline and the number of shots ingested by these birds. This is a publication by David Payne from 2019. It's not just the water birds which are affected, but there are other birds which are ingesting these pellets, mistaken as seeds or as stones to break down the fibers as grit. And you see here it's a common raven, it's a chuka, grey partridge, feather, and wild turkey. And this list goes on, and you wonder which species are all affected by this taking or swallowing down these lead pellets. So what are the sources? As said, it's a use of lead shot ammunition by the shotgun. And when you, as a hunter, aim for a duck in a flock, you hit one deftly, and that's falling down, and others in the surrounding, in a larger distance from the center, might get one or two or a few shots, and they carry on flying. So they're not directly dying from this shooting, but carry on and might end up with this, or like this white-fronted goose, with 5 pellets somewhere in the body. So might be in the breast muscle, might be in the wings, might be everywhere else. And we checked, for example, in this study, several geese species, 3 geese species, which have been caught for avian influenza studies. And in parallel, we did X-rays, and we found that gray-leg geese were carrying lead shot in nearly 20% of the birds. It's a small number, it's only 72 birds we have examined. White-fronted geese, 21%, but bean geese, 38% of the free-living bean geese are carrying 1 or more lead shot pellets in their muscles, in their body. Coming now to the rifle ammunition. Here you see a projectile before shooting and the remaining core body after being shot, and then, which is not communicated by the manufacturers, these are the tiny fragments, the splitters. And there are different constructions of these rifle bullets. Most of them are extremely jacketed bullets. They can have a lead core or double lead core of different types of lead. If you add antibond, then the lead is becoming a bit harder, and they are jacketed and bonded cores or bullets in which the lead core has a special bondage to the mantle. It's maybe too specific, but it's important to know that from these fragments, birds of prey are affected because they're indigesting carcasses or gut piles. Gut piles are the internal organs cut out of the wild boar or the ungulate by the hunter and left in the field to keep the meat fresh and not contaminated with bacteria from the digestive system, for example. And here is also a huge range of raptor species affected, especially those which are scavengers feeding on carcasses or on these gut piles left in the field, like the white-tailed sea eagle, golden eagle, bearded vulture, griffon vulture, Bonelli's eagle, but also common buzzard, peregrine falcon, and so on. We became aware of the problem by analyzing white-tailed seagulls, as I said, as an indicator species and as a surrogate for other birds of prey. And in this graph, there are the results from the mortality. So here we have analyzed nearly 700 dead white-tailed seagulls alone from Germany. And on the left, you see the green bars, which are indicating the natural mortality factors, with intra-specific conflict being most relevant. And on the right, the red bars showing that lead intoxication is the most relevant cause of mortality. So nearly every 3rd or 4th carcass is found has been died because of lead intoxication, followed by collision with trains, unknown trauma, collision with wind power plants, suspicion to poisoning, electrocution, collision with power line and poison, and so on. But as I said, we didn't know about the magnitude of relevance of lead intoxication and lead poisoning and lethal concentrations found in the eagles. We did not just analyze the white-tailed seagull, but also other bird of prey species frequently occurring or breeding in Germany, like the osprey, honey buzzard, red kite, and so on. And you see that it's not just the white-tailed seagull which is affected, but also the red kite, the marsh harrier, and the common buzzard. The peregrine falcon, for example, is not taking carcasses or dead prey. Usually, there are birds, falcons hunting other birds in the air, so they might take pigeons or whatever smaller water birds which have been shot, and from there they got this higher levels of lead accumulation. So after detecting this lead intoxication, we had to prove where it came from. And for that, we used two approaches, the direct and the indirect proof. And in the direct proof, we were able to show that organ alterations are not really pathognomic, but typical for lead intoxication. I will show you later what they look like. We identified fragments from ammunition in the digestive system of birds of prey. We analyzed internal organs like the liver and kidney, but also bones and brain from birds of prey for concentrations of lead. And we used known data published on feeding experiments in bald eagles to see the effect of lead on these birds. And we have the indirect proofs, like the contamination of potential prey, the preclusion of lead accumulation in other prey types, and the low burden in food specialists like the osprey. So once we receive carcasses to our institute, we do a high standard veterinary necropsy in these birds. Every bird undergoes an X-ray, and in a few cases we use a computer tomography to do a full body scan, and then we do the necropsy and do measurements and so on, and take out the organs to process them further. And when taking out the organs, we judge the condition of the organs. And of course, this is wildlife. They're not all fresh. Some of those carcasses are pretty decomposed, but in many cases, we were able to see the liver swellings or the enlargement of the gallbladder and the bile ducts, here seen in the left, or this type of fibrinous pericarditis across the heart of an eagle. So these are good indications that there's something wrong, and this might lead to the diagnosis of lead intoxication. Then we have the X-ray, and on the left you see an X-ray of an eagle with tiny fragments, rarely dense fragments in the gizzard, and when you take them out, you can easily identify these metallic particles as lead. And in the right, we found lead shot pellets in the gizzard of another. After extracting those fragments, we analyzed them by electron microscopy and the XRF element analysis, and found that most of these particles consist of lead, few of iron, and very few of copper or tombak. Then we did an isotope analysis to compare the fragments from the eagle gizzards with ammunition we bought in hunters' shops. And here, the eagle fragments are named with MV for Mecklenburg, Western Pomerania, Brandenburg, Berlin, or Schleswig-Holstein, whatever. And the yellow ones are the ammunition, the bullets bought in the shops. And you see some of them at least nicely clustered together. It's not so easy because, as I said, most of the lead which has been or is used in these bullets is also recycled from batteries, and then you have a mix of all types of isotopes, and you cannot trace back the lead into the mine, from the mine. We then analyzed if with fragments or the proportion of fragments in the eagles, and we found 4 times more splitters and fragments from rifle bullets than from lead-shot ammunition. Why is this? This just reflects the hunting practice in this area where the eagles have been found. And in this area in the north of Germany, most hunters are shooting ungulates, so larger animals, and they're not using lead-shot ammunition, but they're using the bullets. And then we have analyzed the organs of the eagles with the atomic absorption spectrometry to see the concentrations in the internal organs. And from literature, it's known that the background level is around or less than 2 ppm, parts per million or milligram per kilogram. and you have a subclinical to clinical range of 2 to 5 ppm, and then a lethal range starting at 5 ppm. So this is common knowledge, published several times. Sometimes the concentration varies between 5 ppm wet weight and 7 to 8 ppm wet weight, but together with the general impression and results from the necropsy, we think that this 5 ppm threshold is very nice to say that this is a lethal concentration of lead for those eagles. We found or detected a seasonal variance or variability in this concentration. So during the winter times, starting in October, the main hunting season starts also in October, there's an increase, a sudden increase of lead in those internal organs of dead found eagles. Going over November with much fewer cases than December, and ending in March, April, and during the summer months, we don't find any indications of lead intoxication in the eagles. There might by now 1 or 2, but the main number or the biggest numbers we find in the winter. The percentage of lead intoxicated birds during the winter months varies from 10 to 60% depending on the season, or not on the season, but on the year. It's not every year like the other. Then coming to the feeding experiments, this is an interesting insight because this shows you how sensitive the eagles are reacting to lead. And here in this table you see 5 bald eagles, close relative to the white-tailed sea eagle, which have been in captivity for a while, for many years, and they have been fed shots, lead shot pellets from 10 to 156, and they died between 10 and 133 days. So again, there's a huge variability in the response to lead, but what is interesting, that the eagle, number 1 here, or the first one, died with a small amount of eroded lead. And this is just 20 milligrams, which is as little as a quarter of a single pellet, which has been eroded and distributed via blood into the internal organs. And this has been measured, I think, in the liver. So they're much more sensitive, those birds, than mammals or humans are. They're much more sensitive, those birds. I'm coming now to the indirect proof. So this is an X-ray of a roe deer, which has been shot with a rifle bullet, a typical semi-jacketed rifle bullet, and this bullet expands and leaves a cloud of fragments inside the animal. And this was completely new to us. We were amazed to see that such a bullet is producing a cloud of particles in the area where it has been hit. So this was a chest hit directly into the heart, perfect. And then you cut open this roe deer, take out the lung, for example, the heart maybe, or the intestine at least, leave that where you have shot the animal, and take the meat home. And these are the gut parts which might be ingested and might feed the raptors. So as said before, on the left, this is a new rifle bullet with the lead core and the lead tip, and to the right, after being shot. And then we wanted to investigate this further, and we analyzed a total of, I think, 350 ungulates shot from hunters, and to understand the fragmentation patterns, and if this is the case for all types of rifle ammunition or only for specific types of rifle ammunition. And this is a round-nosed tipped semi-jacketed bullet, and you see the small circle. Here is the entrance wound, that's the exit wound, and there's again a fragment cloud. And this is the axis of the shot, how it went through this ungulate, and again we found fragments. So here of this bullet type we analyzed 26 animals, here 15. This is the average number, or minimum maximum average number of fragments in X-ray visible fragments of lead we found in this animal. So we repeated this even with the very modern ammunition, the Evolution RVS, Evolution, that's a bounded bullet, and the manufacturers, they claim that there's nothing left in the animal, but again we found this fragmentation of the bullets. And we did this also with lead-free ammunition, and this is, for example, a partly fragmenting bullet, lead-free, and we only found fewer and larger particles. And again here another type of ammunition, fewer and larger particles of this bullet. Later you will see why this might be relevant to the eagles or to contamination of these animals. In the whole process, I don't go much into detail. We tested all different manufacturers, different types of bullets, and as seen here, it's a huge area of constructing, designing bullets, and the manufacturers want to supply the market with new constructions year by year. And the take-home message is that in all or every case, when a lead-based bullet is used, there is a cloud of fragments. So in 100% of these typical bullets, there's not a bullet producing no fragments. But in the lead-free bullets, you have deforming and partly fragmenting bullets, and in the deforming bullets, you don't have a single fragment left in most of the cases. So we tested here, for example, the Barnes XLC and Labor Naturalis bullets in 122 animals and didn't find a single fragment. Doesn't mean that there might be a fragment, but in most cases we didn't. And then there's another source for the eagles, like this shot, but living water birds like the geese. But also there's carnivore hunting, like this red fox in the left upper corner shot with lead shot pellets and right with a bullet. And again, in this bullet shot fox, you see also, here's the remaining body of this ammunition type, the bullet, and here is a fragment cloud of particles. We looked for data from fish because hunters and other stakeholders claim that the fish is contaminated with lead in Germany, and the eagles are taking up the fish and get accumulated or get contaminated with lead, but the fish is not contaminated with lead, so we could exclude the fish from this example. And as I said, some food specialists like the osprey, which is feeding nearly 100% on fish, had the lowest values of lead. So fish can't be a source for lead intoxication. Coming now a bit to the toxicokinetics and pathology of lead. So it is known, it is neurotoxic, it's impairment of neurotransmission, body coordination, it leads to blindness in the birds. It has an effect on the respiratory tract, and blood forming system. It replaces the iron, so the birds cannot breathe. They are breathing but cannot saturate the red blood cells with oxygen. It's a real cruel way of dying, I'll show you later. And the digestive system is also affected by lead accumulation. We don't understand all mechanisms of lead in the body, but we know that lead is absorbed like calcium, like the calcium ion, and we know that lead is replacing calcium in the synaptotagmin protein, which is responsible for the fusion of the neural vesicle with the membrane to release the neurotransmitter. So this is blocked by lead. Here, I don't know if I can start it from here. No. Somebody needs to push.
Well, just you need to mouse to start
on the screen. It's not a touch screen. Thank you. Here you see a white-tailed seal brought to the institute just for euthanasia, because this bird was heavily affected by lead intoxication and it could not really stand. It's a bit shaky, it's nervous, and this is why it is standing, otherwise it would lie down all the time, and it cannot really react to external features. It's really sad to see that, so we can skip this probably. So it's tumbling. In the next video shows even a more affected eagle in the clinics, and this eagle is not able to stand, and it's breathing but cannot saturate the red blood cells with oxygen, and you see it's really depressed. Normally they're really emaciated, and because it's wildlife, they try to avoid contact to humans, and you can catch them only at the very end when they're too weak to fly off and to move away. So this bird was also euthanized. I don't want to go too much into detail into the kinetics regarding the uptake of lead. We just need to understand if the eagles are feeding on carcasses or birds and they take up a sufficient amount of lead, then they are dying within a few days, 2-3 days, and they're dead. But if they also are able to uptake smaller amounts of lead on a repeated basis, and then they accumulate lead, they can be affected by chronic lead accumulation, and then they develop blindness and they cannot move their body, they cannot hunt anymore, then they starve to death. Or, which also happens, they just consume small amounts of lead, and this lead is processed, not really processed, but moved into the body, into the blood, into the organs, and then finally into the bones, because bones are the lifetime deposit for lead, and then they survive this, and you can track the lead exposure, lifetime lead exposure later in the bones. What is the effect on the population of white-tailed seagulls? Just because of this additive mortality from lead, we have a delay in population saturation of estimated 15 years. So luckily enough, the white-tailed seagull can cope with this additional mortality. It's just a shift in this population saturation. That means the carrying capacity of the habitats in Germany. And this graph shows the correlation between age and lead in bones. And there's a significant correlation, of course, as they are older, they're accumulating more lead. But what is really interesting here is that this is the area where no concentration, or very little concentration of lead has been diagnosed in the liver, but high amounts of lead in the bones. Those are birds which survived the lead uptake and are displaying high concentrations in the bones over the time. And these are around 30% of the eagles we have seen. So 30% are dying directly from lead, and another 30% have faced lead during their life, sometimes to clinical or at least subclinical levels. Coming to the solutions, it's pretty easy. Without access to contaminated food, there wouldn't be any lead intoxication. So that would mean to remove the viscera from the field, or not shooting water birds with lead shot ammunition, and the carnivore control should stop. And even then, with a number of 1.8 million ungulates just rodeo shot in Germany annually, and a very conservative estimate of 1% not retrieved carcasses would end up with 18,000 animals laying somewhere around in the field, and might be a source for lead intoxication in these raptors, because raptors start to feed where there's a body opening. They start to feed on the wound channel, and around the wound channel we have the highest concentrations of lead, so it's easy for them to get to take up this lead. But there are solutions. There is lead-free ammunition, like this lead-free shotgun ammunition. There are different brands, different types, but when hunters are switching to this lead-free ammunition, it's not that easy. You cannot switch one-to-one. You have to change your shooting, your aiming behavior, because a steel shot is faster than lead. They have to aim not too much before the shot, before the duck, the flying duck, for example, and they have to use a pellet type larger than compared in steel than to lead, for example, or they use a stronger load of powder in the cartridge, and then they can shoot the same distance as the lead before. Otherwise they have to reduce the shooting distance, because with steel you can only shoot ducks at a distance of 30-35 meters, and with a normal lead shot ammunition you're shooting ducks at a distance of up to 50 meters. So there is some adjustment to this new ammunition type, which is not as pronounced as in the rifle bullets. In rifle bullets you can directly switch to lead-free ammunition. You just have to find the right bullet type for your rifle. So again, here's also a bit of adjustment necessary, but there are all calibers now available. You don't need to read this. This is just to show you there are many calibers available for hunting, and in most of these calibers, lead-free ammunition is available. And then there was this idea that this lead-free ammunition is not killing as good as the lead-based ammunition because there are no splitters. And it might be the case that if you're shooting an ungulate, it's moving away and you cannot find it, and there's more pain to the animal because you're switching to lead-free ammunition. So we tested this killing efficiency by digital X-ray in the field of wild boar, of ungulates, of roe deer and red deer. You have to understand the wound channel, and we found that there is no real difference in the killing capacity of lead-based versus lead-free bullets. So it's nearly the same. It mainly depends on the shot placement. So if you have a good shot placement into the chest, into the heart, then it's absolutely the same. There are different wound channels and different cavities depending on the ammunition type. And we tested that also by shooting these bullets into ballistic soap and then calculated the energy released into this ballistic soap, which is correlated with the size of this chamber. And it popped out that not the material is responsible for the wound channel, but the energy released within the first 15 centimeters. So the energy, the construction not, but the energy release, depending on construction and powder, is necessary to kill an ungulate. And this is, for example, the effectiveness of lead-based and lead-free bullets. And they're nearly the same, but at the beginning, when the manufacturers provided the market with lead-free ammunition, there were some types of lead-free ammunition which were not performing as good as lead-based ammunition. And this caused irritation by hunters, and though they thought, okay, this new type of ammunition is not as good, but the manufacturers overcome these problems, and nowadays they are at least as good as the lead-based bullets. So we did many studies on showing that the energy is sufficient to kill animals. We did also feeding experiments in white-tailed seagulls, so we put iron nuts, which are completely untoxic to the eagles, in carcasses, and found that the eagles are avoiding these iron nuts by 73%, and as large as a nut, as higher is the avoidance rate. So larger nuts here to the right are completely avoided, but smaller nuts are swallowed. So this is interesting for the construction of new ammunition, new bullet types. Few fragments, large fragments are more likely to be avoided by eagles than the very small and those numerous fragments produced by lead-based ammunition. But of course, you can assume it's not just affecting raptors or predators, it's also affecting humans. And this is also known for many years. For example, the EFSA, European Food and Safety Authority, wanted to establish a threshold level until that lead uptake is harmless to humans, but they found that there's no such an effect, there's no such a threshold, it couldn't be established. The smallest amount of lead is harmful to humans, so it's affecting more infants, children, but also embryos in pregnant women, because there's a higher demand for calcium, and this higher demand also results in a higher absorption rate for lead, the same as for calcium. So they are more affected than adults, for example, and one uptake of in one meal or once in a life is reducing the intelligence quotient in a child lifelong, for example. And then in adults, it's affecting the kidneys, the kidney function, and resulting in high blood pressure, but also in the likeliness of developing cancer. But we are used to that by now. There are fake news. The AFEMS, that's a lobby organization for promoting sport and ammunition, mainly sports ammunition, but also hunting ammunition. They claim that lead makes you beautiful and healthy, so why not use lead anymore, or why not continue using lead? But there are some classical barriers for hindering the transition of hunters to switch to non-toxic ammunition, and this is results from the German discussion with the stakeholders, with the hunters, by looking for solutions which can be shared among the hunters. This is the tradition or the original technical issues, so the construction, as I explained, changing, sociopolitics, industry resistance, the price, and there were many complaints, but by now most of these complaints have been overcome, and many hunters have been switched or are switching to lead-free ammunition, and the different types of bullets are increasing year by year. So it's pretty easy to communicate that, and this is very important because there are many hunters in Europe. I think the highest number of hunters is in France with more than 1.3 million. In Germany we have 350,000 hunters. In Croatia there are around 55,000 hunters. These figures might not be the most recent ones, but gives you an estimate or just an overview about the hunters in Europe. Just from hunting ammunition, it is estimated that more than 44,000 tons of lead are brought into the environment. We communicated those results from our long-term study with, by producing a web page, a leaflet, brochures, workshop, and a conference. And we also published these results in scientific literatures from home range size about the use of eagles, of feeding behavior, food choice, but also comparing erosion of organ accumulation rates, all different aspects, and took the stakeholder concerns really serious, and also initiated follow-up studies of this, because some said that the deflecting behavior of lead-free ammunition is more dangerous in these lead-free bullets than in lead-based bullets. So this has been tested thoroughly, and the result was that there is no more danger from lead-free bullets compared to lead-based bullets. Then we tested, not we, but another institution, the University of Eberswalde, tested the suitability of lead-free bullets under real hunting conditions, and they questioned more than 11,000 hunters and asked for the performance of lead-free ammunition, and also tested their energy release. So these are mainly the results from this study. And then, of course, consumers' aspects when eating game meat during, I don't know, Christmas or main hunting season. And there is a threat for intensive consumers to have a higher load of lead than people who are rarely or never eating game meat. This is the way of lead drawn from a Scandinavian hunter when they are shooting water birds or moose, for example, and this lead is ending up in eagles, in foxes, or in humans, and that's what I have shown already before. And the current situation in Germany is that lead shot ammunition is forbidden for shooting water birds in wetlands, and in 500 states it's also forbidden to use lead shot ammunition in rifle bullets. So there is some progress in banning this lead for hunting, but in the more conservative states like Bavaria, we probably have to wait many centuries before they will ban it. And therefore, this, for example, the Conference of the Parties in 2014 in Kyoto, there was proposed that lead-based ammunition should be banned in the whole of Europe, and this has been adopted by the Conference of the Parties. And in the meantime, the Americans also investigated more and more the consequences of lead ammunition for their raptors, for their bald eagles and gold eagles, and found that their populations are suppressed by nearly 4% for the bald eagles and by nearly 1% for the gold eagles. We did a similar statistics and modeling for raptors in Europe, and found that just because of lead intoxication, around 55,000 raptors are missing here. So, because this has been communicated for many times, as I said, we started our investigations 20 years ago. Others have investigated the same problem in the UK, in the US, in Japan. The Spanish investigated these problems, and because of that, the European Chemical Agency proposed as a restriction on lead shot ammunition in 2017. This restriction has been adopted by the European Commission in 2022, and at the beginning of this year with the new hunting season in the springtime, this had to be implemented in the national laws of all European countries, just for the lead shot ammunition. And for the rifle ammunition, the proposal has been sent in by September 21, and this is the roadmap. It has been drafted, and the different commissions have commented on that, and the REACH committee has to discuss this, and this has to be sent by the European Commission in the last quarter of this year or at the beginning of next year, and then a ban of rifle ammunition can be expected at the end of next year or latest at the beginning of 2025. So that's the end, that's the actual or current state of the legislation. Thank you very much for your attention. I know this is a dry topic, but I'm glad that you were able to listen and to follow, and I'm happy to take your questions. If you have.
Hi. Thank you for this very interesting lecture. I was wondering, you mentioned the effect of lead on embryos in humans, but do they have any, do they do anything to the eggs of birds, of the development of the embryos of birds?
We didn't find any indications for lead intoxication in embryos in birds. We tested some eggshells and the yolk of eggs for lead, but the concentrations were not really alarming. We tested some eggshells and the yolk of eggs for lead, but
maybe I would just ask to explain better this missing raptors slide. What does it mean that we miss them? If it's like it's about carrying capacity, or it's about is this 40% of let's say big vultures are, so we have now 86 of possible big vultures because of lead poisoning, or it's another case? It's a very rough estimate for all raptors, so it's taking into account that different raptors are affected to different amounts of mortality. So for example, in white-tailed sea eagles, it varies between 14% in some countries up to 50% in other countries. And the white-tailed sea eagle, together with a griffon vulture, is the species, those species mostly affected. So there's a higher toll for those species than for peregrine falcons or common buzzards. So in the publication, you will find species-wise the effect on direct mortality on the overall population in Europe. So in the publication, you will find species-wise the effect on direct mortality.
Just a question about the lead ban in Germany. Has there been any efforts to try to reduce the negative effect of lead ban on hunting population regarding the prices of lead-free ammunition, especially lead-free shot, which is, we know, it is far more expensive than the lead shot. Has there been any effort in compensation of the price from the government?
You mean if the price has been compensated somehow? No, not in Germany. I mean, you're right. In most cases, lead-free ammunition can be more expensive, but it depends. For example, the lead shot, the steel shots, are cheaper because they are, I think, Wojtek, you know more about that. There's a Croatian manufacturer which is providing cheaper steel shot than lead shot ammunition. But this is only for the shotgun, of course. And for the bullets, it depends if you compare high standard, high quality lead-based ammunition with lead-free ammunition, then it's comparable in price. But there's very high or very pricey lead-free ammunition available, absolutely. But when you see the typical hunter shoots per season on animals maybe 20 times, so there's not such, I mean, hunting in per se, at least in Germany, is a price-intensive hobby. And the additional costs from ammunition is nothing which would stop the people from hunting. So in Germany, at least, the numbers of hunters is increasing, especially young people who are interested into receiving nice game meat, lead-free. They are caring about mass production. They want to harvest their own meat, and they're doing their hunting license. So it's not stopping them from hunting.
Yes, especially the education, the way you are doing presentations like this are actually the best way for people to start thinking and move on.
Thank you. But I know, for example, in the US, in some national parks, like in Teton National Park, there are some voluntary programs, and there nature conservationists, they have supplied hunters with lead-free ammunition to make them more aware of the problem and to get them to their side. And after having concerns, after using lead-free ammunition, they were convinced they're as good as lead-based ammunition. So this would help in some cases, definitely. After having concerns, after using lead-free ammunition.
So lead-free ammunition is not toxic to humans or animals in any way. I mean, the materials that are made of, they're not toxic when ingested.
I would recite Paracelsus in this case. The amount makes toxic, or makes the material being toxic. So the difference between lead, for example, and copper is that lead is not a trace element which is needed by anybody or by any organism. So it's toxic in any case. But copper is a trace element, and we need copper for maintaining our functions, our physiological functions. But of course, you can receive a copper intoxication. But so far, and there have been tests regarding game meat and copper concentrations in this game meat, and they were of no danger for humans. What is known is that copper, for example, is a toxic for limbic environments, so bacteria, but also protozoa and Daphnia, for example, they are easily affected by copper intoxication.
My institution, we have a rescue center for griffon vultures, and I just want to share the same problems that we have in Croatia, because we secure some samples of blood and some tissue, and it is proved that some birds are affected with lead. It's very well known that griffon vultures are like a species that is affected with lead, and it's the same in Croatia. But our population it's not so big, only 130 breeding pairs, and also the situation on the islands where we have this breeding population is specific, because there are lots of one boar and cow deer that are invasive species in terms of islands, because doing great damage on the ecosystem, and there is a huge problem, because hunters they have to remove, to eradicate these species, and of course the vultures have the benefit because they feed on the carcasses, but on the other way we have the problems with lead poisoning. So we had some cases of lead poisoning proved in our birds. So yeah, this is the problem that we are interested in, and that we are dealing on a daily basis.
And you were able to convince the hunters to switch to lead-free ammunition, or to discuss the problem, or make them aware about this lead intoxication? I mean, they're affected by themselves.
Of course, there have been some projects, and of course with Beyond, and they also secure some bullets for free to convince the hunters that the specific performance of the bullets is the same. Yeah, but I think that the main problem is maybe the price or something in Croatia, because I think that the hunters are still using the ammunition that is maybe cheaper or that are used to. So this is like also some kind of problem. But of course we are waiting for the ban, of course, and but yeah, it's a huge problem. I think it's one of the main problems for griffon vultures for us, besides electrocution and some other mortality causes the poison with lead is alarming. Yeah, and I wanted also to comment on this. When you say like a background lead, it is not. It is a background level, but this bird also ingested some lead, but it's not lethal for bird.
The background level is considered being somehow natural. So,
but it's how come it's not natural because you said it's not in the organism.
Right, but they all the lead is taken up with their food.
Yeah.
And we have some lead in the environment because of batteries. Sometimes you wonder where you all find batteries in biocompost and in garbage dams, and even in some plant material you find higher lead concentrations depending on the ground. For example, in mining areas, it is known that plants as well as animals living in these mining areas of lead, for example, showing higher concentrations than animals or plants outside those mining areas.
Maybe a question, but not for Oliver, maybe for Oleg or for veteran to tell us what is the situation like in Croatia? What are the attitudes of hunters toward lead-free ammunition?
Okay, I will be more better for that. 2 years ago we did this survey for with hunters of the preferences to switch to lead, non-lead shot, so only hot shot, and then 13% in post-op. 13% of people said that they will switch, but a huge amount, 5% didn't know. Only 30% was like, no. So there's a lot of people who need that better. They decided 2 years ago with rifles. From our experience, there's no resistance, there's no opposition. People are usually there is no big opposition for non-lead rifle bullets. The shot is this, which rises for our experience, this emotion, but maybe there will better answers will be given now.
I do some research and that way. So main problem in Croatia with non-lead shot is all the weapons. You talk about 30% of people who want who maybe go they use non-lead shot, but problem is all weapon and standard in Croatia is so bad. That's the main problem here. No problem to price of bullet or something.
So you mean that there's a lot of old shotgun which would not be able to shoot?
For rifles, there hasn't been that much resistance with lead-free shot, lead-free ammunition. But the main problem again is actually here is the price of the cartridges. Because when you take average rifle ammunition, you can get lead-free and lead ammunition for the same price. But when you go on low cost, you will not find low-cost ammunition. Like for less than €2, you will not find lead-free ammunition, but with lead ammunition, you have quite a few to choose from. One of the problems in Croatia is, of course, that we have really many hunters. Quite a lot of them are looking at first at the price of the ammunition and then the effect on game. So the cheapest bullet for quite many hunters is the best one, unfortunately.
This is logic, as what you say, absolutely, but it also depends on the demand of ammunition types. And for the moment, this lead-free ammunition probably in Croatia is just a niche market, so there's no high demand or request for lead-free ammunition. So with an increase on demand, maybe from a ban, then the prices for lead-free ammunition will drop. This is extremely likely, so to say. There will be manufacturers which will provide the market with much cheaper copper or atomic ammunition. And regarding the old shotguns, I mean, Gamebore, for example, the manufacturer here producing lead or steel shot ammunition, they say you can use shotguns down to the age of 1954. Older weapons you cannot use, but weapons since then, shotguns you can use because they provide this wad, in this case a biodegradable wad, and this wad prevents the barrel by being abrased or overused by the steel shots.
Okay, but you have one more problem. Full choke. You know,
full choke you cannot use for steel, that's sure.
All guns all have full choke.
Yeah.
I do some research 5 years ago, and I know what they're talking about.
Yeah. I did my hunting license 13 years ago, and I know not, at least for Germany, only few hunters have a full choke, and often the choke you can remove and replace by a quarter choke or by a no choke. It depends. I mean, if you do sport shooting, you have often the full choke, but for shooting water birds, you're using it. But yes, you're right. The choke is a problem, and you have to tackle that. Yeah. Sport shooting, you have often the full choke, and for shooting water birds, you're using it. But yes, you're right. The choke is a problem, and you have to tackle it.
Okay, if there are no more questions, there are